all kinds of fun stuff to get to today. So let me go ahead and go through our agenda. Hopefully, you have your pencil and paper. I know it's been a while since before winter break, since we've been doing math together. But if you need to run and go grab something, go for that right now. Um, Remember that this little section right here, practice time, is where you can list any questions that you had throughout the week. And if it's one of those weird questions that you really can't type, like perhaps maybe you had to draw a graph or something like that, you can tell me it was lesson number whatever in unit 4, number 8. And I would go and I would look that up so that I would know which one you were talking about. But so don't be afraid. I always send out the agenda a day or two ahead of time so that you can add any questions that you had along the way. So I didn't see any this week, but that's all right. Our goal, of course, is still the same as it is during reading, and that's to communicate and to collaborate with each other and to have a lot of fun while we're practicing the skills that you are working on in math. So, if you take a look down here, I have circle graphs. That's one thing that you're going over right now. Bar graphs. Bar graphs are pretty easy, so we might not spend a whole lot of time with those. We touched on those two before winter break. And then your new topic is probability. So we have a couple different lessons there. So I'm going to go ahead and start with circle graphs, and we're going to do just some practice problems. And some of this might be new to you, and that's totally fine. You might learn something new about circle graphs today. I'm not going to even pretend that I can draw a circle graph either, so I might be taking a lot of screenshots of these pictures. Okay, here we go. Whew, all right. Circle graphs. Let's get started. Okay, so they have given us, oh, sorry, let me move my screen around just a little bit so I can scroll up. Okay, so they've given us this circle graph here with different plant types. It says a plant nursery in Richmond keeps records of how many plants are annuals, biennials, and perennials. It doesn't matter what those are. That's just a different type of plant. But you can see by the graph that it's 1/5 are perennials. I know nothing about gardening, so this is this is new for me. 1/5 is biennials, and 3/5 of the plants are annuals. So, if the nursery has a total of 140 plants, how many more annuals than biennials does it have? So, if you take a look at this problem, this is a two-step problem. First, I have to find out how many annuals there are. Then I have to subtract how many biennials. Okay, and that's going to give me the difference between the two. Give me a thumbs up if that makes sense. Okay, so we're going to find how many are in the 3/5 and subtract this 1/5 section. So they told me that there's 140 plants total. So let me just kind of show you how I would work this problem out. If I could get to sketch along the bottom. Goodness. If I have my pen on my little pad, it like makes everything just really hard to move. That means nothing to you, but anyway. All right, so whew. So this might be new to you. 3/5 of 140. Yes, go ahead, Nicholas.
Um, so, uh, um, if if you didn't have to find out exactly how much, you could just do 2/5 more. But you
Yes,
do have
yes,
to
that's
find out exactly how much, so.
yeah, exactly. You could totally do it that way as well. I'm showing how to do the difference, which would give you the exact same answer, but you can also find out what 2/5 would be, and then you'd have the same answer as well. So we could kind of look at both ways, okay? And when I
Mhm.
say the word of, so 3/5 of 140 total, That means multiplication. So anytime you hear that word of, it means to multiply. So let's figure out what 3/5 of 140 is. So when you multiply fractions, it's really simple. All you need to do is just do the top times the top and then the bottom times the bottom. So let's figure out what 3 times 140 is. This is probably mental math, but you can come over here and do the problem on the side. That's not a big deal. Okay, and then of course 5 times 1 is just 5. Now, this is a division problem. So let's go ahead and put the 420 under the house and divide by 5. And that's going to tell me what 3/5 of 140 is. So I'm going to give you just a minute to do this problem. When you get the answer, type it into your chat. Oh, hi, Jacob. I'm glad you came in. Right now, we are looking at a circle graph, and I'll show you the picture again in just a second. But what we're doing is finding what 3/5 of 140 is, and then we're going to subtract 1/5 of 140. Okay, so Autumn gave us 84 is the answer to this division problem. So just remember, I'm going to show you the picture again. 84 plants are annuals. Okay, so now let's figure out the 1/5. So we'll do the problem again. 1 times 140 is 140. 5 times 1 is 5. So now this is a division problem. Put your 140 under the house and divide by 5. Go for it. Very good, Sierra. I'm going to wait for just a
My
couple more people.
my computer is malfunctioning. Can I just say it when everyone has an answer? Because
Your
I can't
chat's not
tap.
working?
Yeah, my chat is like whenever I tap it, it comes up and then disappears before I can type anything.
Oh, weird. Okay, yeah, that's fine. What did you get, Nicholas?
28.
Good, very good. And yeah, Sierra, you just messed up just a little bit. The answer was 28. So now all I have to do is subtract 28 from 84. Go for it. Go ahead, Nicholas. What'd you get?
56.
Beautiful. Okay, so now let's go check it out. So what this means is that 56 are perennials, 56 are biennials, and 84 were annuals. So, yay, there we go. So this is a little bit more complicated than what just reading a circle graph is. This is actually figuring out percentages. So we're going to keep working with this because it's a good skill to know. All right, we have a new graph, and it shows a veterinarian in Newton treats a number of different kinds of animals every year. So here's the different different fractions. 1/6 are rabbits, 1/12 are birds. Looks like most of them are dogs, 5/12, and rodents. Where are the cats? Anyway, whatever. Um,
Yeah.
Rodents are 1/3. So now this one's actually pretty easy. We don't have to work out any problems. This one just asks us which list is arranged from the most common pet, dogs, to the least common pet. And you can just tell me A, B, C, or D. Go ahead, Sierra.
B.
B, that's right. So you can see dogs are first, rodents are the second most treated, Rabbits are the next most, and then birds are last. Good. Okay, so here's another problem where we're going to have to work out the percentages. So this is good practice. So we have the students at Townsend Middle School, and they were asked to vote on their favorite donuts. Yay! 4/7
What? Old
like
fashioned.
old fashioned, and then 3/7 like chocolate. So just slightly more kids liked old fashioned. If
1/7.
161 people were surveyed, how many more people voted for the old fashioned than the chocolate? So really, if you look at this graph, like Nicholas was talking about earlier, we could do it two different ways. We could find out what 4/7 of 161 is,
Or
and
you
then
could
we can
find out
find
what
out
one
what
seventh is.
3/7 of 161 is, and we can do the subtraction. We can do 4/7 minus 3/7. Or why don't we just find out what 1/7
Yeah.
of 161 is? So I wanted to show both ways so that we kind of knew that that's what we're doing. So 1/7 of 161. Now remember, I'm just gonna, because a couple people came in late. Whenever I say the word of, I mean multiply. Okay? So 1/7 of 161. Sierra, what's 1 times 161? 161.
161.
Beautiful. And what is 7 times 1? Go ahead, Sierra.
7.
7. Beautiful. Sorry, my cat just hit my pin. There we go. So now, to solve this, we turn it into a division problem. Put 161 under the house and divide by 7. I'll give you a couple minutes to do that. Okay, so I see a lot of hands up and a couple answers in the chat. What did you get, Nicholas?
23.
23. Perfect. So it looks like 23 more kids enjoy old fashioned than chocolate. Cool. All right, I want to see. Oh, very good, Jacob. You came in there just at the last minute. All right, one more practice problem, and then we'll kind of do a check for your understanding. The survey was conducted to learn about people's chocolate preferences. Okay, this is making me hungry. Yeah, 2/5 of people liked milk chocolate, and slightly more, 3/5 like white chocolate. Oh, this is easy. Which type is less popular?
Milk.
Yes, milk
Milk
chocolate.
chocolate
Okay.
is less popular than white.
I know, that's kind of weird. I don't believe that. But
That has nothing to do with math.
My mom hates milk chocolate. She says dark chocolate is the best.
oh,
I hate
it
white
has a lot to
chocolate.
do
I
with
think
math.
it's way too. It's not like chocolate to me. White chocolate. I like
No,
milk chocolate way more.
I agree. I kind of like dark chocolate because they tell you it's better for you, but whatever. Okay, so now we get to actually do some work. Some players in a co-ed basketball team compared the total number of points they scored over the course of a year. So looks like this is our star player who scored 3/8 of the points total. Jaden did pretty well though too. This kiddo scored 1/4 of the points. Erica and Rana and Lucia, I guess, only scored 1/8 of the points total. So if there were 144 points scored overall, how many of them were scored by Jaden? So let's go find Jaden. He scored 1/4 of 144. So I'll set that problem up for you. We need to figure out what 1/4 of 144 is. So this turns into a division problem. Go ahead and put your 144 under the house and divide by 4. Go for it. Nicholas, give everybody a second. You're fast.
I got it before you even set up the problem.
Because you are just a quick little dude. That's why. But we'll give everybody a second because it's a good skill. Sierra's ready. Let's give Autumn and Jacob one more second. And Lucas, if you're still there. Okay, good. Sierra, yeah, go ahead and type it into the chat once you get it. Sorry, Nicholas, I know you can't, but. Good work, Jacob. Good work, Sierra. And I bet Autumn is just about finished, and Lucas as well. She's typing it in. Perfect. That is right. Jaden scored 36 of the total points. All right, guys, let's see so I can move on to our other skills by
Wait,
a
hold on.
show of hands or
Wait, hold
thumbs.
on a second.
Okay.
If he scored 36, if you divide 144, you could divide each number and then add all of those numbers together. So you could divide 4 by 4, and then you would get 1, and then, 1. Oops. Never mind.
It's okay. That's all right, Jake. Nicholas, it's okay to think out loud. We were just finding 1/4 of 144. So.
Yeah, I accidentally did, instead of 11, I adding on 25, I added 14.
Oh, okay. No problem. But let's see by a show of thumbs if we are good with reading circle graphs and then finding percentages like we were just practicing. So a thumbs up or a thumbs down, or you could put a happy face into the chat or a sad face. Yay! Very nice. Okay, so this was actually a little bit more complicated than you really had to do in some of your coursework, but I thought it was worthwhile to show you. We are going to move on. If we have time at the end, we'll come back to bar graphs because, like I said at the beginning, they were pretty easy and we spent some time on those before break. I'd like to move into probability. So I have a couple different fun little interactive lessons for us. So here we go. You're okay, Lucas.
They really slice people in half.
All right, we're going to skip the intro. That's hilarious. But all right, we're going to go ahead and get to our probability
To
lesson.
zoom in, they saw people in half, and then they unsaw them.
Yeah. Okay, so here we go. In this episode that we're going to watch, and so we are switching gears into probability, Hank and Chelsea can't choose between heads or tails, so they toss a coin to decide. Here we go.
Wait, what? No, what?
If I toss this coin in the air, is it more likely to land on heads or tails?
I'm not sure. There must be a way to figure out which side it's more likely to land on.
Let's take a look at probability. That should help us.
Okay.
Probability is the likelihood of a particular event occurring. For example, we can determine the likelihood of a particular color being randomly drawn from a bag of marbles. Let's put 3 red marbles into the bag. When we draw 1 marble out of the bag, what are all the possible outcomes? Click on the box next to each possible outcome, then click on the check button. You may choose more than one outcome. Clicking on the selected box will deselect it.
Okay, so you guys are going to help me out. If the bag contains only red marbles, what am I going to draw?
A red marble.
Okay, so that one's very simple.
And if you flip a coin, it's 50-50.
That's right.
It's completely, I mean, you can't decide unless you decide, like,
Complete
take
the
it
chart by
in your
clicking
hand
and
and then
dragging
put
the
it
word
and
that
set it
describes the
differently.
probability of drawing a red marble from the bag.
Okay, so what's my probability of drawing a red marble? Always or never?
Always.
Always. Very good.
When there are only red marbles in the bag, a red marble will always be drawn from the bag. Let's see
It'll
what
get a little
happens when
harder.
we add 3 blue marbles to the bag. When we draw 1 marble out of the bag, what are all of the possible outcomes? Click on the box next to each possible outcome, then click on the check button. You may choose more than one outcome.
Okay, Nicholas, so what are my possibilities of drawing a red one out of the bag?
50%.
Good. And so that means 50% for blue as well.
Yeah.
Good.
Click and drag the word that describes the probability of drawing a red marble from the bag.
Oh, what do you think, Autumn?
Equally likely.
Beautiful. See, they're starting off pretty easy for us, but correct.
Click and drag the word that describes the probability of drawing a blue marble from the bag.
Okay. Well, we already know that that's equally likely.
When there is an equal number of red and blue marbles in the bag, a red or blue marble is equally likely to be drawn.
It'll get more
Let's remove
complicated.
2 red marbles from the bag.
There we go.
Even though there are different numbers of each color, the outcomes remain the same. We will still draw either a red or blue marble from the bag, but the probability has changed.
Yes, it has.
Click and drag the word that describes the probability of drawing a red marble from the bag.
What do you think, Sierra?
Wait, least likely. Less likely.
Less likely. Very good.
You'd have a 25% chance of drawing a red marble.
That's right, and that's exactly what Jacob just typed into the chat as well. If you have 4 total, then each one is worth 25%. And so red is 25%, and then blue would be 75%. Beautiful.
Click and drag the word that describes the probability of drawing a blue marble from the bag.
You guys are quick.
Mm-hmm.
When there are more blue marbles than red marbles
Probability's
in the bag,
fun, though.
a blue marble is more likely to be drawn, while the red
When I
marble
was in
is
4th
less
grade, we learned stuff like this, and it got like I don't know, like 12. It was.
Yeah, it's going to get more complicated. Okay.
Now we will conduct an experiment to determine the probability of drawing a blue marble from the bag. Before we do, let's make it more interesting by adding 1 yellow marble to the bag.
There we go.
We must also add yellow as a possible outcome on our chart. Let's predict the probability of drawing a blue marble. Click on the box of your choice, then click on the Enter button.
Okay, so this one's pretty easy. We haven't done percentages yet. So, Nicholas, what about blue marbles?
You would have a 60% chance to draw a blue marble.
So that's more likely, right?
Yeah.
Good.
For this experiment, we'll draw a marble from the bag 50 times. We'll record the results on this frequency diagram. Each time a marble is drawn, we will record it and then return it to the bag.
Okay, so
We'll
they're
add a
going to
tally to the chart each time a particular color is drawn. We'll then use the tallies to determine the frequency or the number of times each color was drawn. Click on the Draw Marble button to draw a marble from the bag.
All right.
Repeat this.
Woo! Here I go. I'm going to go all the way up to maybe not 50. I don't know. We'll see. Woo! Woo! So total number, I've drawn 5 times. That's what you're seeing on the bottom there. And they are tallying it up for us. Oh my goodness.
Any reds?
Go blue.
I know. I'm going fast, man. Woo! All right. That's
To quickly complete the remaining 40 trials, click on Complete the Trials.
okay. There we go.
Take a moment to compare your prediction with the results. Click on Continue when you're ready to continue.
Okay, so when we look at this, when we said more likely, we were exactly right. We were more likely to draw that blue marble. And then it looks like red and yellow tied. We can find the percentages here in a minute as well.
You can conduct this experiment again to see if the results are different.
Nah,
Or you can...
we'll move on. Oh, we have a spinner.
A spinner.
Let's
Oh,
conduct
yeah,
a
one of those
probability
things.
experiment. This time we will determine the probability of spinning a particular number on this spinner. First, we must determine all of the possible
What the heck?
outcomes
They
of
just
spinning.
chopped off her head.
When we spin the spinner, what are all of the possible outcomes? Click on the circle next to the answer of your choice.
Okay, so what are all the possible outcomes? Possible. So it doesn't mean more likely or anything, just possible. Go ahead, Autumn.
The spinner will stop on 3.
Well, that's most likely, but the possible outcomes are
Oh,
one, two, two, or three. So,
B.
yeah, B. Very good. Oh, incorrect. Oh, it appears twice. Okay, it doesn't matter. There we go. One, two, or three.
Let's predict the probability of the outcomes. Click on the box next to the prediction of your choice. Then click on the Enter button.
Okay. So now, what do you think, Sierra? What is the probability?
To stop on 2. So
It is
B.
more likely to stop on two because that takes up a whole half of the spinner. Very good. Yay!
For this experiment, we'll spin the spinner 40 times. We'll record the results on this frequency diagram. To speed things up, we'll give you 5 identical spinners.
Okay.
You will have to keep them all spinning until you have run a total of 40 trials.
Oh boy.
Click the spin button for each spinner.
Can I do it? Ah! It's gonna take forever. I'm going as fast as my little old fingers can go.
It'd
Just
be easier if you were doing it on an iPad.
it would be because I would just be yeah, exactly.
You'd just
I
be
basically
tapping.
just put my whole entire hand over it and
Beep, 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 beep.
It looks like 3's getting more.
yeah, you just never quite know. I mean, just because it is more likely doesn't mean that's always how it turns out.
Take a
Yeah,
moment
so
to compare
we
your
only got
prediction with
2
the results.
ones.
Click on
Out of that
Continue when you are
entire
ready.
time, we got 2.
Yeah, go ahead, say that again, Nicholas.
Well, out of the entire 40 times we spun it, we got 2 number ones.
Yeah, I know, because number one was a really small little section. And so, yeah, as Jacob just said, yeah, that three went crazy. It wasn't as probable as the two, but it was still a pretty big space. So there was a pretty good opportunity for three to show up. I wouldn't have expected it to tie with the two, but it did, and that's possible.
Let's try the
Anything is really
experiment again.
possible.
This time you can choose the spinner you would like to use. If you want, you can use the same spinner that we just used. Click on the spinner of your
Ooh, do the
choice.
really complicated one.
Okay, I'll do the really complicated one. Is this the one you were thinking?
The one that goes
Click on the
1,
box
2,
next to
1,
the
5,
prediction of your
1,
choice.
4.
Then click
Oh.
on the
That one.
Enter button.
Here. Okay. Ah! Oh no.
Now we will conduct.
I know. Sorry. Oh, see, when I went back and tried to use the other spinner, that's okay. Don't worry about it. We have other little games that we're going to play.
Now we know enough about probability to determine whether the coin will land on heads or tails.
When the coin is tossed in the air, is it more likely to land on heads or tails? Click on the circle next to the answer of your choice.
A, B, or C? Go ahead, Autumn.
C.
Yeah, it's equally likely. Yay!
Just for fun, let's toss the coin. You can guess which side it will land on.
Heads.
Head.
Click to choose heads.
Tails.
Yeah,
Then
you
click
guys
on
go
the
ahead
toss
and
button
type
to
into the
toss the
chat
coin.
what you want to guess.
Repeat this as many times as you want. Then click on Continue.
Okay, so I have one vote for tails. I have one vote for heads.
Tails.
Looks like Sierra wants heads too. Nicholas
Tails.
wants tails, and Nicholas and okay, so more people want tails. It was heads, I think. All right. So
Impossible to tell.
was it tails? Either way, that's fine. Okay.
You know, for adults, they're kind of dumb.
Oh,
Well,
They get their heads chopped off.
they did get their heads chopped off a little bit. Yeah,
Well,
that was
well,
unfortunate.
still, I mean, should know better than to question which side will be more likely.
You would think that they would, but sometimes adults forget things because we're old.
Maybe they could show little 2-year-olds. That would be really great.
That would
They
have
would
been more
be like,
likely, huh?
what is the probability of this?
Okay, so I'm gonna move on. I'm drawing these marbles that they had shown us earlier. So, it looked like in that bag they had one red marble, the three blue marbles, and then the one yellow marble. So, they did all of those less likely, more likely, equally likely type of problems, but what they didn't do was the percentages, and that's kind of what I wanted to focus on right now. So, how many total marbles are there in my bag? Sierra?
5.
Okay, so there are a total of 5. So to find the probability, and I'm just going to say I'm going to stick my hand in one time and draw out a marble. The probability of drawing a blue marble would be 3/5. Okay, and the probability of drawing a red marble,
1/5.
1/5, and of course the
20%.
yellow.
20%.
Exactly, 1/5. And so Nicholas recognizes this as a common fraction or common percentage, which equals 20%. So,
Because if the bag, it always has 100% of the marbles,
yeah,
because that's the number it is will be 100%. So you just divide 100 by 5 and it equals 20, and then you change that to percentages.
that's right. Very good. So, you have a 60% chance of drawing one of those blue marbles, right? So 20 plus 20 plus 20 is 60. 1/5 chance of drawing the yellow, and then a 1/5 chance of drawing the red. So that's just kind of how those percentages would have worked out. They used the words less likely and more likely, but okay. So let's move on to my second little game that I had. More probability. I love probability. It's fun. Okay. So now we're going to look at probability as a fraction. So we're going to kind of go through like a deck of cards, and they're going to give us some problems and ask us basically, if it's a good deal or not, basically. So if we have a good chance of winning. So Jacob, we are doing probability again.
What game of cards is it? Poker?
I think they just kind of mix it up. Okay, actually, that's not what I wanted to do. Sorry. There we go.
Sam and I were hanging out before school. Sam said that if I pulled a jack out of the deck of cards on my first try, he would buy me lunch. But if I didn't pull out a jack, I would have to buy him lunch. Before I jump into this deal, I want to calculate the probability.
That's good. Okay, so first of all, before we even go any farther, how many jacks are there in a deck of cards?
And a
Nicholas?
correct one.
Yeah, and Autumn's holding up her fingers. There's only 4 jacks total, and there's 52 cards total. So right away, I kind of know that this is not a good deal. But we'll go
You
on.
could get 48 other cards.
First,
Mhm.
find the number of favorable outcomes. I know that each deck of cards has 4 jacks. That means I have 4 favorable outcomes, or 4 chances. I know that each deck of cards has
Oops,
4.
sorry. There we go.
Next, we need to figure out the number of possible outcomes. There are 52 cards in a deck, and I have an equal chance of picking any one of them. So that means there are 52 possible outcomes.
Except for jokers.
Probability can
If you had jokers, then it's 54, and there's only
place the
2 of
number of
those.
favorable outcomes over the total possible outcomes.
Okay, so this is what we were just doing when I was showing you the marbles. We were putting the number of favorable outcomes over the total possible outcomes.
So our fraction is 4 favorable outcomes, me picking out a jack, over 52 total possible outcomes, all the cards in the deck. The probability of me picking a jack is 4 out of 52. We can reduce that to 1 out of 13. Those odds don't sound too good to me,
No.
so I think I'll pass.
Yeah, that's a pretty bad deal if you took that.
The probability of me picking a jack.
I haven't simplified fractions in a while.
We can
Didn't
reduce
think
that to
about that.
1 out of 13.
Yeah. Okay,
odds
sorry,
don't-
they repeated that. All right, so let's test ourselves. Now that we kind of, saw what they were doing with the cards. How many favorable outcomes are expressed in the fraction 12/25? So favorable, remember, I'll just review for you, goes on top. So how many favorable outcomes are there, Nicholas?
There is 12 favorable outcomes.
That's
over
right.
25 possible outcomes.
And 25 possible. Good. Okay, how many possible outcomes are expressed in the fraction 3/38? So possible outcomes is the bottom number. Good, Jacob. Good, Sierra. Go ahead, Sierra. What were you going to say?
38.
38. Perfect. Which fraction correctly shows the probability of 14 favorable outcomes and 37 possible outcomes? So A, B, C, or D? Nicholas?
D.
D. Very nice. 14 favorable out of 37 total. RJ is watching a soccer match. He has seen players with the numbers 14 to 22 on their jerseys. If the players are coming on the field at random, what is the probability that the player will have an even number on his jersey? Ooh, this is going to take just a minute. Okay, so 14 to 22. Let's go over here, and I'm going to wipe this clean. So I'm going to write all the even numbers, 14, 16, 18,
22.
20, and then 22. How many total outcomes are there? 1, 2, 3, 4, 5. How many probable, I'm sorry. I messed that up. I got to get my little eraser. Hold on. All right, well, I'm just going to cross it out. I can't find my eraser. Sorry, so 5 favorable outcomes. How many total possible outcomes were there? It looks like there were 22 players, right? So,
No, wait, no, that's just the numbers.
oh, that's just the number. I'm sorry. So it looks like, okay, he's watching the soccer match.
9. Because there's 9 numbers total.
There's 9 between 14 and 22. That's right. So let me go back and show that. So if I count all the way from 22 to 14, oh God, my pen is terrible. There were 9 possible. Okay, so favorable would be 5. Which fraction correctly shows the probability of 7 favorable outcomes and 28 possible outcomes? Ooh, they reduced the fraction here. Autumn, what do you think?
I think it's A.
Tell me why you think it's A. You're correct.
Because if you do 28 divided by 7, it's 4.
Mhm.
So, huh?
Oh, good. Keep going.
Oh, I thought you said something. And then you do, like, you put, ugh, I don't really, but it's just like, you go 7, wait, hold on.
You
I don't know
reduced
how to
the
explain
fraction.
this.
No, it's okay. I'll show it on the whiteboard. Basically, you
Simplify.
just reduced your fraction. 7,
We'll simplify.
28 can be reduced to 1/4 because 7 will go into itself 1 time and 7 goes into 28 4 times. So there we go.
And it's called an equivalent fraction.
Equivalent fraction. Okay. Of the fractions listed, which one best represents least likely? So least likely to happen. Do I have a 1/4 chance? Is that pretty likely? A 1/2 chance? That's pretty likely. 1/8 chance? That's pretty small. Or a 1/3 chance? Go ahead and type it into the chat, and then Nicholas, I'll let you talk. Very good, Jacob. You got it. Go ahead, Nicholas. What do you think?
I think it's an 8 because it's the smallest and it would be the least. If you had a spinner, then it would 1/8 of a chance would be much smaller than anything else. It would be the least likely.
That's right. That's right. So 1/8 is the smallest fraction. Okay, last question. RJ is playing a game with his brother and sister. The game uses a 6-sided dice. If RJ rolls one of the dice, what is the probability that he will roll a 2 or a 4? So total is 6. 2 or a 4. Nicholas, what do you think?
1/3 of
A
a chance.
1/3 chance. That is correct. Let me show it on the whiteboard. Okay, so just ignore this problem. Okay, so we have 2 out of 6 chances. That reduces to 1/3. And I know that because 2 goes into itself 1 time and 2 goes into 6 3 times. So yes, a 1/3 chance. Good. Yay! 100% correct, guys. So yay. All right. Before we leave, are there any other questions that we can answer today about circle graphs or probability or even a bar graph question? Feeling pretty good?
What about line graphs?
We'll move into line graphs, but we haven't really needed to go there yet. So line graphs are actually pretty easy.
They go over time. They represent a matter of time, not a number of things. They usually do
They
a
can,
number
yeah.
of something changing over time.
Okay. So Jacob, is there a question we could answer for you, or I'm not really understanding your comment there. So maybe you can send me a private message. Sierra, yes, Bridge to Terabithia needed to read chapters 1 and 2. You're going to need to check out that book club site to figure out what job you were responsible for next week, okay? All right, guys, it has been fun. I'm going to wait for just a second to see if Jacob types me any other questions. Everyone else, you're free to go, so give me a wave goodbye. Bye.
Bye.
Happy weekend. Almost. Okay, no questions from Jacob. All right. All right, guys. Well, I hope today was fun. I will see you next time.
Miss Bruns?
Yeah.
I found this movie. It's called The Perfect Human Diet. I found out that when the reason are we have some people the reason people have asthma is because we eat grains.
Huh. Really?
Yeah. So and and when we and the reason the Neanderthal evolution the reason they have such big heads is because they ate much more meat.
Really?
So it's
Well,
pretty interesting.
that is
So my
pretty
dad is
interesting.
doing the diet and he eats meat for every single meal.
Oh, is that the Atkins diet?
Uh, I don't think so. I think it's
Oh. Well, you should share
perfect.
that article with me. I'm kind of curious because I have a little bit of asthma. So maybe
Yeah,
there's.
it's an entire movie about it, and then there's a book about it too. But
Huh. Yeah, that
it
sounds pretty
also
cool.
turns out that the the stuff we give to cows to fatten them up is the same food pyramid.
Oh, yeah. Well, yeah, those hormones that we give to the cows to fatten them up, yeah, that definitely has an
That's the
impact
food
on humans
pyramid.
for sure.
All right. Well, I just wanted to tell you that because I thought it was pretty interesting.
That is pretty cool. Well, yeah, share that movie with me. I want to watch it.
Mhm.
All right, Nicholas. Well, you did great today. Thank you so much for all of your help, and I will see you next time.
Okay. See ya.
All right. Have a good day. Bye.
You too. Bye.